Welcome to Algebra 2, Lesson 5-1, nth roots, radicals, and rational exponents. Let's think about this essential question as we look through the examples. How are exponents and radicals used to represent roots of real numbers? Let's look at example 1. How do we find all real nth roots? So remember that real roots are roots that are possible. And you can see by graphing, right? You will see that the roots are often represented as the x-intercepts. So let's think about the real nth roots. What are all the real cube roots of 125? So let's think about 125. Before we do that, let's look at the vocabulary words. An nth root of a number c is x, such that a number to the nth power is equal to c. So it's the opposite of the power. An nth root can be denoted by a radical symbol with an index of n. So this is called a radical symbol, the root sign, nth root of c, and c is called a radicand. And recall that here, if you have an nth root of c, c is the radicand, but you can change this to 1 over nth power, right? So c to the power 1 over n is the same as nth root of c. So remember the properties of exponents. To represent the real cube root of 125, write x equals cube root of 125. And then you're going to find a value where a number to the cube power is going to be 125. And luckily, we have an integer. 5 cubed is equal to 125. So 5 is a real root. See if there are other roots. And how do we know if there are other roots than just a real root 5? Well, you're going to set the expression equal to 0. X to the square minus 125 should equal to 0 if we use this equation, right? So subtract 125 on both sides, and then you can factor them out and solve for x. And the discriminant, if you check, has a negative. And there are roots that are not real. So 5 is the only real cube root of 125, but it doesn't mean it's the only root. There are 2 other imaginary roots. And remember the conjugate theorem, where if you have one imaginary root, the conjugate of that complex root is going to be also the root. And so the complex numbers, the complex roots come in pairs, right? So it makes sense that you have one real root and 2 imaginary roots. Okay, so let's continue in part B. What are all the real fourth roots of 16? So now we're going to find all the real roots of 16 to the 1/4 power, right? So the index is 4, radicand is 16, so you can write the radical symbol, fourth root of 16. And then figure out the roots. You'll see plus and minus 2 will be the positive and negative real roots for 2. And then if you solve for x squared plus 4, this is going to have 2 imaginary roots where you have I, right? And so the real roots, you're just going to find the real roots. Real roots of x fourth to the x fourth equals 16 are 2 and negative 2. Okay, so not too hard. You just need to solve the equation. So find the specified roots of each number for parts A and B. Pause the video, come back when you're ready for answers. Okay, are you ready? Let's look at part A. Real fourth roots of 81. So fourth root of 81. And you can set it up so that x to the 4th power is equal to 81. And solve for x. You can solve an equation like this, and then you can rewrite this as x squared minus 9 squared. And now we have difference of squares. You can factor it out easily using these squares. And then you'll see that the root for this one will give you plus or minus root 9, which is plus minus 3. And this one will give you plus or minus 3i. And so the real roots are just plus or minus 3. And then part B, you do the same thing. Rule cube roots of 64. So rewrite this as x to the third power is equal to 64. And then you solve for the equation for zeros. And then you'll see that only positive 4 will give you positive 64, right? So when it is cube or odd number degree, you have a specific positive or negative numbers. You have a specific sign. So it's just positive 4. All right, let's look at example 2. Understand rational exponents. What is the meaning of the exponent in the expression 16 to the power of 1 over 4? To interpret a rational exponent, look at what happens if you extend the properties of exponents to rational exponents. So you remember the properties of exponents. The power property is when you have a power to the power. So if you change the base of 16 and rewrite it to the base of 2, you get a power to power property, right? 2 to the 4th power is 16. And then if you substitute that, you get 2 powers. And so power to power, you have to multiply the powers, right? And so 4 times 1 over 4 just cancel each other out. You have 2 to the power of 1. And then that's just equal to 2. And that is really the same as 4th root of 16, where these two are the same expressions, right? So 4th root of 16 is just 2. So this means you can define 16 to the 1 over 4th power to be 4th root of 16, or 2. So in general, for positive integer n, x to the power of 1 over n is defined to be nth root of x. So this is the fractional power. So let's look at part B. What's the meaning of exponent in the expression 27 to the power of 2 over 3? What if we have an n as a denominator, but then you have something else other than 1 as your numerator in your power? Then you can separate them also using the power property. So 2 over 3 really means 27 to the power of 1 over 3 to the power of 2, right? Because if you multiply them, you'll get 2 over 3. So you can go the other way using the power property as well. And then you can use the definition of exponent to rewrite 27 to the power of 1 over third power to the third root of 27, right? Because they're the same thing. We just learned that, right? And then you know the cube root of 27 is just going to be 3, positive 3. And so that's just 3 squared, which is just 9. So if you simplify it, it's really easy. It's a simple number. So let's look at try number 2. Explain what each fractional exponent means, then evaluate. Evaluate means solve for it, make it simplified, right? And so explain what they mean, use the properties if you can to simplify, and then evaluate. Pause the video, come back when you're ready for answers. Okay, are you ready? All right, so part 8, 25 to the power of 1 over 2. What does the fractional exponent 1 over 2 mean? The fractional exponent 1 over 2 means it's the square root. It's the square root, right? The nth power, nth root. Second root, or the square root, means the square root of the base 25. And so how can we evaluate this and make it simple? So 25 to the power of 1 over 2 is just square root of 25, which is just plus or minus 5, right? Yeah. Let's look at part B. What does the fractional exponent mean? 2 over 5. The fractional exponent two over 5 means it's the fifth root. But what about this 2? It's the power of 2, right? So this means 32 to the power square to the power of 1 over 5. And so it's the fifth root of what? Of the base 32 squared, right? So this is how you write the meaning in words. You basically interpret it in roots and the base with the powers. And then if you evaluate this and simplify, what would you get? So remember, 32 could also be written as the base 2. And I think that makes it even more simple. So 2 to the power of 5 is 32. And then to the power of 2 over 5, I combined this again. And so you can multiply the powers by the power property. And so 2 over 5 times 5, it just cancels out the 5. And so 10 divided by 5 is just 2, right? So 2 to the square is just 4. And so this is just 4. Simple. Isn't it beautiful? Yeah. Okay, so that was example 2 in try 2. So we looked at the concept of fractional exponents and simplifying them. So this is the concept summary, interpreting fractional exponent. The index of the radical is equivalent to the denominator of a fractional exponent. And remember, the index means it's the nth root of the radical means root. So index is the nth root. N is the index. It's the number of how big of a root it is, right? And the radical is the root. Okay, so this is the number. Index is the number, radical symbol is the root symbol. Is equivalent to the denominator of a fractional exponent. So fractional exponent just means you have a fraction in your exponent power, right? So in general, nth root of c is a real number. Furthermore, if m is an integer and m over n is in lowest term, so if this is simplified, then you'll be able to rewrite this as c to the power of m to the power of 1 over nth power, or nth power of c to the power of m. So these are all equivalent, okay? So please keep this in mind. Let's move on to application. Example 3. Evaluate expressions with rational exponents. Part A, evaluate the expressions 32 to the power of 3 over 5, 27 to the power of negative 2 over 3, 50 to the power of 3 over 4. So remember that the fractional exponent means your power for the numerator, and then the nth root in your radical for your denominator, right? So 32 to the power of 3 over 5, you can rewrite them using the power property to as a multiplication of 1 over 5 times 3. And then you can rewrite 32 as a base of 2. 2 to the power of 5 is basically 32. And then this one cancels each other out. So you just have 2 to the power of 3. And so 2 to the power of 3 is 8. So simplified form would just be 8. And then 27 to the power of negative 2 over 3. Negative power does not mean your base is becoming a negative. Negative just means you're dividing your base that many times. So remember, 2 to the power of 1 is 2. 2 to the power of 0 is 1. Anything to the power of 0 is 1. And why do we do that? Because every time the power increases by 1, we multiply the base one more time, right? But if we go the other way, every time we subtract the power by 1, we divide the base from your original number. So 2 divided by itself is 1. Any number divided by itself is 1. And so any number to the power of 0 would be 1. And then -1. You subtract 1 again in your power. You divide 1 by the base. 1 divided by 2 is 1 over 2. Okay? And so on. So negative power property says anything to the power of negative, let's say a to the power of -n is always going to be 1 over a nth power. Or anything to the power of, let's say, 1 over a to the -nth power is also a to the nth power. Because why? This is really 1 over a to the nth power, which is 1 divided by 1 over a to the nth power, which is 1 multiplied by a nth over 1, which is a to the nth power. Okay? So in this case, you're doing the same thing. You can first use the power property to separate your fraction into two different fractions into a multiplication, and then simplify because 27 is 3 cubed. So 3 cubed to the power of 1 over 3 is just 3. 3 to the power of -2 now becomes 1 over 3 squared, and that is 1 over 9th. So this is your final answer. And then 50 to the power of 3 over 4. 50 doesn't have a perfect fourth root, so you can just rewrite this as 50 to the power of 3 fourth root, right? Or you can approximate. It's going to be about 18.8 if you use a calculator. So sometimes you don't have an exact answer like that, and you may need a calculator. So in a quiz, you'll probably be able to use the scientific calculator, but not a graphing calculator. Let's look at part B. The Fujita scale rating F of a tornado is represented by this equation. F equals cube root of W divided by 14.1, all of that squared, and then all of this minus 2. Where W is the estimated wind speed of the tornado in miles per hour. What is the Fujita scale rating of a tornado with estimated wind speeds of 100 miles per hour? So what kind of information do we have? We have two variables missing, F and W, right? F is the Fujita scale rating, and we are finding the Fujita scale rating F. And estimated wind speed is represented by W, and that's given, right? When W, in other words, when W is 100, what is F? That's basically what this is saying. This is the equation. When W is 100, what is F? And so you write the equation with the substitution of 100 instead of W, and then you solve for that equation basically. And then you can simplify as much as you can, but this is not going to be an exact answer either. So you'll be able to use a calculator to divide that as well. But you need to know how to evaluate the exponent by yourself, or simplify your equation by yourself. Using the properties of exponents. So it seems like F is about 1.69. So tornado with estimated wind speed of 100 miles per hour is classified as F1 according to the Fujita scale. Well, or about 1.69. Yeah, but in the scale, if you just round down, I guess. So this is an application problem. Let's look at try question. What is the value of each expression? Round to the nearest hundredth if necessary. So this is not a word problem, but it's a good practice to simplify our expressions. and evaluate. So round to the nearest hundredth if it's not an exact solution. Pause the video, come back when you're ready for answers. Okay, are you ready? Let's look at part A. We have negative parentheses 16 to the power of 3 over 4. Parentheses is very important because if the negative was inside the parentheses, then and your power was on top of the parentheses, then you would also have to apply that power to the negative. So then it becomes more complicated. But it is outside, so whatever you have in the parentheses, you can simplify and then put a negative. Okay, so let's look at the next step in trying to solve this. So 16 could be rewritten with a smaller base, right? You can use a base of 4 or you can use a base of 2, right? So 2 to the power of 4, because 2 to the power of 3 is 8, and then times 2 would be 16. So 2 to the power of 4 is 16, or you can do 4 to the power of 2, right? So either way. But since your denominator is equal to 4, just rewrite it with the base of 2. 2 to the power of 4 is 16. To the power of 3 over 4 would be your power. And then you simplify. 4 times 3 over 4 is just 3. So then you have negative 2 to the third power. And then that's just equal to negative 8. So your answer is negative 8. And then part B. Let's look at part B. Fifth root of 3.5 to the fourth power. That is really 3.5 to the 4 over 5 power, right? But that's really fifth root of 3.5 to the fourth power, which is 150.0625. And then you use the calculator to figure out the fifth root because it's not going to be an exact solution. So that's really 2.724296895 ... So you can round it up to be about 2.72. Okay, good. So that was example 3 and try 3, the application part. Let's continue with example 4, simplifying nth root. How do we simplify expressions with nth root? So let's look at examples in part A and B. Fifth root of 32m to the power 15. Remember, this power 15 is only on the variable m, and don't just assume this is also including 32 because there is no parentheses. If there were parentheses like 32, parentheses 32 and parentheses close and then 15, then you would have to put a power of 15 on 32, but that's not the case. So then you just have to worry about this separately. So first of all, you can rewrite 32 with the base 2. 2 to the power of 5 would be 32. And then m to the power of 15 could stay. But then remember we have a radical sign to the fifth power. So you can rewrite this as 2 to the power of 5 and the m to the power of 15, all of that to the power of 1 over fifth power. But you can also combine this and say, oh, m to the power of 3 to the power of 5 is equal to 15. So I can group 2 and m cubed together, right? And then this is like a distributive property. 5 distribute here times 1. 5 times 3, 15, right? So it's like a distributive property. And then you can rewrite this like this, and then you'll see that this is really, the radical sign is really 1 over fifth power, and then really it cancels this out, right? So then you just have 2m cubed, and that's as simplified as you can get. So you can stop there. Yeah, sometimes finding the same power with the radical, the index of the radical would cancel it out. And of course, you have to change some numbers with different bases if you can rewrite them as different bases. Let's look at part B. We have fourth root of x to the power of 20 times y to the power of 8. And so you can group them and then make all of them into a power of 4. So how do you group them? You have x and y, and you want a power of 4. And you know you can get it because 4 is a factor of 20 and 8. So 4 times 5 would be 20, and 4 times 2 would be 8. So you factor them out, factor your powers out. Yeah, and then this will cancel the radical and the power out, and you'll just get the absolute value of x to the fifth power, y to the fifth power. Why do we have the absolute value here? We have to have a positive x fifth and y squared because why? Because if we have a negative inside the for the radicand, that means we have an imaginary number, and we don't want that. We want to stay real. Like, yeah, you started with a real number, and so we're assuming that everything is real, and we want to keep it real, and so we're going to put an absolute value sign just to make sure that it makes sense. And so y squared is always going to be positive, no matter what y is, right? So you can just put the absolute value sign in the x as well. So when you simplify them, put the absolute value sign when necessary. Okay, so this would be your final answer. Let's look at try number 4A and B, simplified expression. Pause the video, come back when you're ready for answers. Okay, let's look at part A. You have cube root of negative 8, a cube b to the 9th power. Yeah, so in order for this to be real, we already have a negative sign here. So either a or b has to be negative. So we're not going to put an absolute value sign because either a or b has to be negative. So don't worry about absolute value for this one because we want it to be positive. All right, so this one, let's rewrite this as 2 to the power of 3. And then we have a to the power of 3, b to the power of 9. Or you can write this as b to the power of 3 to the power of 3. And then this is all to the power of 1 over 3. And then so you can distribute it out, cancel it out, and then you end up with negative 2ab cubed. Okay, part B, we have fourth root of 256, x 12th power, y 24th power. And so in this case, we will need absolute value sign because we want the radicand to be positive and 256 is already positive. So x needs to be positive, y needs to be positive. Otherwise, we want both x and y to be negative, but it's still gonna be positive, right? X to the 12th power is gonna be positive, y to the 24th power is gonna be positive anyway. Yeah, but anyway, so this one, we will be able to rewrite 256 as 4 to the 4th power. Yeah, or 2 to the power of 8. Right? And then x to the power of 4 to the, we want the power of 4. So x 12 times 4. Wait, no. X, you divide 12 by 4, you have 3. X cubed to the power of 4, right? Then you have y 6 to the power of 4. And then we know this is all rooted, fourth rooted. And so this canceled, this out, this out, this out. And then we are left with 4 absolute value x to the cube power. Why do we need absolute value here? Because x to the cube may turn negative if x is negative. And so we have to make sure that this stays positive. Then y to the 6th power is always going to be positive. So if y to the 6th power is always positive, we know x cubed has to be always positive. So that's why we put absolute value sign here to make radicand stay positive. Okay, now we've learned how to simplify nth roots. Let's use nth roots to solve equations. In example 5. So solve the equation 2x to the 5th power equals 64. So in this case, we want to use all the properties of exponents and then solve for x, right? So you can divide 2 on both sides first, right? Because this is 2 times x to the 5th power. And then we have x to the 5th power is equal to 32. And then change the powers. You can power both sides by the same power, and that is still still the same equation. If you power both sides, then that's okay. Yeah. So x to the 5th power to the power of 1 over 5 will give you x to the 1st power. So we want that. 32 to the 1 over 5 power really is 2 to the power of 5 to the power of 1 over 5. And so these powers cancel each other out. So you just have x is equal to 2. So the solution of the equation is just x is equal to 2. Okay, let's look at try number 5a and b. Solve the equation 5x cubed is equal to 320 and 2p fourth is equal to 162. Pause the video, come back when you're ready for answers. Okay, are you ready? Let's look at part A. 5x cubed is equal to 320. And so the first step, you can divide both sides by 5. X cubed is equal to 320 divided by 5, which is 64. And then you can power both of them by a cube root, right? You can cube root both sides. And so x is equal to cube root of 64, which is just 4. It has to be positive 4. So x is equal to 4. All right, 5b, solve the equation 2p fourth power is equal to 162. Same thing, divide both sides by 2, and you get p to the 4th power is equal to 81. And then you fourth root both sides to get p is equal to 4th root of 81, or this is 4th root of 3 to the 4th power. And so this is 3 to the 4th power to the power of 1 over 4, and that's just 3. Yeah, but this could also be plus or minus 3 because no matter positive, if it's positive or negative 3, it should still work, right? Yeah, negative 3 times negative 3 times negative 3 times negative 3 is also positive 81. So plus or minus positive 3. Yay! So that was example 5 and try 5. Let's look at the last example. We have a concept of solving an equation in the form x to the power of n minus c. So to solve the equation in the form where x to the power of n is equal to c, you find the nth root of both sides, just like we did, by raising each expression to the 1 over nth power. And then you can simplify using properties of exponents. All right, let's look at example 6. Use nth roots to solve problems. One cube-shaped container has an edge length 2 centimeters longer than the edge length of a second cube. So the edge length, if this is x, you have x plus 2. The volume of the larger cube is 729 centimeter cube. When the larger cube empties into the smaller cube, how much water will spill? So the water that will spill would just be the water that is left over from the volume, right? So whatever the volume of the bigger one is, the volume of the bigger one minus the volume of the smaller one would be all the leftovers. So that's what we're trying to get. Okay, so set up an equation. X plus 2 to the power of cube. This is a cube, so all the edges are the same length. So side times side times side would be the volume. So x plus 2 cube would be 729. And that and that would give us an equation to solve for x. And then once we figure out x, we can figure out the volume for this one, for the smaller cube, and then we can subtract them to figure out the volume of the water that will spill. So first of all, set up the equation, solve for x, which is 7. And your x could only be positive numbers. It doesn't make sense that edge length is going to be negative, right? So if you have any negative numbers in this situation, it's not going to work. The volume of the smaller cube is 7 cube now because x is 7. And so 7 cube is 343. So now we know the volume of the smaller cube. We can subtract them, and if we do, we have 386 centimeter cube left. So when the large cube empties into the smaller cube, 386 cubic centimeter of water will spill out would be your final answer. Okay, so this is a word problem that could possibly happen in real life. You'll see it in the quiz or the test. So let's practice. Try number 6. One cube has an edge length 3 centimeters shorter than the edge length of a second cube. So it's the same kind of problem. The volume of the smaller cube is 200 cubic centimeter. What is the volume of the larger cube? So pause the video, see if you can figure this out by yourself. Come back when you're ready for answers. Okay, are you ready? So let's think about the 2 cube. We have 2 cube that are different in size. The one cube has an edge length 3 centimeters shorter than the edge length of a second cube. So if we find that the edge length of the second cube is x, if we assume that this is x, then the volume of the first cube is x minus 3, right? And the volume for the smaller cube could be written as x minus 3 cube is equal to, which is given 200. And then you solve for this to figure out x, right? And x is equal to the edge length of the bigger cube. So then x minus 3 is equal to cube root of 200 if we cube root both sides. And then x is equal to cube root 200 plus 3. And then you can use a calculator to figure that out, which is about 8.848085 ... And so volume of the larger cube would be x cubed. And so that's really cube root of 200 plus 3 cubed. And so you can use the calculator again, and you see 692.6926283 ... So the volume of the larger cube would be about 692.69 cubic centimeter. 69 centimeter. Okay, so check your answers, see if you got it right. If you did, good job. Let's summarize our lesson. So 5-1 is about nth roots, radicals, and rational exponents. So relating the radical and exponential forms are something that we should have looked at in Algebra 1, right? So the radical form is when you use the root, and the exponential form is when you use the power. And they could be written in different forms, but they could be converted to each other. Yeah. So the radical form to exponential form could be written like this. The exponential form to the radical form could be written like this. And these are some examples. So remember the properties of exponents and the switching of the forms. That was 5-1, nth roots, radicals, and rational exponents. We'll continue with the next lesson in the next video. Bye, guys.